All right, ladies and gentlemen, it's time for us to do the last of the five factors that influence our climate, our weather, and it is ocean currents. You know, we already talked a little bit about that in terms of how Great Britain and Europe have warming Gulf Stream ocean currents that provide warmer weather than they would be expected to have based on their latitude. I'm a mess. I just got done cutting the grass and doing all sorts of yard work. I don't want to put myself on camera looking like this, so let's get started with number 5. Here is the 5th important factor when it comes to climate, and that is ocean currents. And there's a lot for us to talk about when it comes to ocean currents. Let's start with water and the fact that water flows away from the equator. Because of the way the Earth turns, the way the Earth spins on its axis, water has a tendency to flow away. There are some other very important terms for you in this section, and one of them is called a gyre. Sometimes you hear it pronounced gyre. These are prevailing winds that change ocean currents. You know that the winds are going to have an effect on the water, at least on the surface of the water. We're going to talk about upwellings. That's a big deal in environmental science. So you need to understand the concept of what upwellings are. I'm not worried so much about thermohaline circulation. I'll show you a graphic on that, or heat transport. But this is the other big one. El Nino, also called ENSO. The El Nino Southern Oscillation. You have got to understand where it happens, what causes it, in depth. So let's get to it. Here is a diagram showing you the oceanic circulation patterns, and it's really important for us to note some of the interesting things that are happening here. First of all, you notice the red lines are showing you different ocean movements, and here's the one that I brought to your attention in class a couple of weeks ago. You know, the Gulf Stream, and how the Gulf Stream comes across our coastline and then sprints across the Atlantic and bathes Europe in warmer than normal temperatures. You know, once again, here's England and Ireland. They should be cold. They should be cold like Canada is, but they're not, thanks to that ocean current. Well, there are other ones too. You can see here there's the South Equatorial Current. It goes counterclockwise. You know, we have the Pacific Ocean Current. It goes clockwise, pardon me, it goes clockwise. And these different patterns are important for you to note. Not so much memorize or anything like that, but just to understand that these oceanic circulation patterns, because large bodies of water moderate temperatures, have an effect on the weather. And no better example of that than here in Europe, thanks to the Gulf Stream. These areas are called areas of upwelling. You can see them shown to you in blue here. And this is the ENSO one. That's the big one that we're going to discuss later on. I've got a video that I want to show you here, but I'll tell you what, I'll save that for class. Remind me to show you this quick little video later on. Alright, so what is an upwelling? Ordinarily, we have warmer ocean water on top, and then colder, denser water down at the bottom. But because of surface currents, they oftentimes will push the warmer water away, and that enables the colder water to come up, and that's why it's called an upwelling. Why is it a big deal? Because there are a lot of nutrients in that bottom layer of water. Even though it's colder and denser, that bottom layer of water has big nutrients, mostly because of decomposers. You know, everything that's ever died in the ocean ends up falling to the bottom eventually. And also it supports a large population of producers. Remember that NPP thing. So when upwellings occur, these nutrients come up to the surface and provide wonderful nutrients, and that makes all of the fish life better. So upwellings are a really, really great thing for fishermen. In fact, fishermen are bound to let you know when they're happening. They kind of know based on the prevailing winds and what's happening on the coastline where they're at. They will be very busy fishing when an upwelling is in the offing. Okay, here's that thermohaline circulation. Thermo means heat. Haline means salt. And if you don't know that, you're just going to have to memorize it right here and right now. Haline is salt. So we're talking about movement because of temperature and because of the salt concentration of the ocean water. Okay, for instance, the remaining water up here, up in the very, very far north area, because this warmer water makes its way up and eventually cools and begins to freeze, and maybe even some of it will evaporate, the remaining water is saltier and denser and sinks to the bottom. And that's what happens way up here in the north. So the ocean waters are definitely saltier up here near Greenland, which is frozen over basically anyway, and all of these Arctic areas here. But cold water travels along the ocean floor because it sinks to the bottom, and it connects again with the world's oceans, and it becomes part of another current. And you can see that these currents happen near the Indian Ocean here, and also here in the Pacific Ocean. Cold, deep water eventually rises to the surface and ends up circulating all the way back to the North Atlantic again. So this is just a way to show you kind of an overall circulation pattern. What's important for you to remember is the water is saltier up here in the north, and that these currents happen on a regular basis. I mean, this kind of movement, this kind of circulation of our oceans is occurring all the time. And that's why our ocean waters continually move. All right, this is just giving you the definitions. Moving heat and nutrients around the globe, very, very important in the movement of our oceans. Just to come back here for a minute, I wanted to make the notation that what happens, there's a real concern about what happens if these icebergs begin to melt, and we know that they are melting. That is putting a tremendous amount of fresh water, and that's dumping the fresh water into this area of the ocean. That fresh water is going to dilute the salt content here. Well, that could have a major effect on the whole thermohaline circulation, because the whole idea is that the water up here where number 2 is saltier and denser, sinking to the bottom. If that doesn't happen, then we don't get this return movement down here. So there's big concern that climate change and the melting of the icebergs will continue to dilute the saltiness of the water and have a real effect on the thermohaline circulation. And I don't think we need to go any further on that. All right, one other thing to note is the heat transportation that happens when it comes to large bodies of water having that moderating effect. And all of this graphic here is telling you is what I told you about England and Ireland. Their average winter temperature is 20 degrees Celsius, 36 degrees Fahrenheit warmer than Newfoundland, Canada, and that's where they are latitudinally. That's where they ought to have weather like Newfoundland, and they do not. they have weather 20 degrees warmer. That's because of the heat transportation that happens with that Gulf Stream coming up our coast and then swinging across. All right, the other very, very important concept in this chapter is ENSO, El Nino Southern Oscillation. So what do you need to know about El Nino Southern Oscillation? First of all, where it occurs. It happens on the eastern Pacific coast of South America. The eastern Pacific coast of South America. Not right on the equator, although some people will talk about this as an equatorial phenomenon. It really isn't. It happens right here along the eastern Pacific coast of South America. Now, ENSOs, El Ninos, have an impact on weather all around the world. So you have to be careful what's being asked. If it's asked, what's the impact of El Nino, or where is the impact of El Nino felt? It's felt most everywhere around the world. But if you are asked, where does El Nino occur? Then you'd be talking about the eastern Pacific coast of South America. Remember that blue wedge that we saw for upwelling? Alright, so what normally happens is the trade winds, remember the Hadley cells, the trade winds blow in this direction most of the time. They blow from east to west. As a result of that, it literally pushes warm surface water of the Pacific towards Australia and towards Southeast Asia. This movement of warm water allows for the cold, deeper water to push its way up. That is the upwelling. And this is why some of the best fishing that ever occurs in the world occurs right here in this area of South America. Think of Chile, Bolivia, Ecuador, these areas here. I think of Chile mostly. And that country enjoys great fishing along its coastline because the normal state of affairs is to have lots of upwellings. Now what happens because of an El Nino? What happens is the trade winds weaken, and so we do not have this movement of warm water. Oh, I wanted to mention one other thing about the normal year. Literally, if you could imagine the Pacific Ocean like a small bowl of water, the winds literally push the water towards Australia. The sea level is much higher over here as a result of these trade winds. Just like if you were to tip the bowl a little bit, there's more water, more of the Pacific Ocean's water is over on this side of the ocean than it is on our side of the ocean, normally. During an El Nino year, the first thing that happens is the trade winds weaken. So now this warm surface water is not being pushed from east to west, but rather it's enabling the warm ocean waters to stay on the surface. Now there are no upwellings. It prevents upwellings. And during an El Nino year, you can bet the fishermen are hating that, because now they don't have any upwellings. They don't have good fishing anymore. The cold water stays down here. The warm water stays on top. And really, because the trade winds have practically shifted directions, now the sea levels on this side of the ocean are higher than they were over here with Australia. Now, what are some of the impacts? I don't know if I have that slide here. I have a video I want to show you of it. Well, some of the impacts are, in an El Nino year then, because there's no movement of water, surface water, warm surface water, towards Australia, they dry out. And I mean, during an El Nino year, they will have a very, very hard time with droughts. Terrible, terrible droughts. I mean, so much so they have to find other sources of food because the drought conditions become so severe. Just in case you were wondering what happens with an Enzo. I can remember living in San Diego, and the weatherman reporting that our weather was happening because it was an El Nino year. It was happening during an El Nino. When do these trade winds weaken or reverse? About every 5 or 7 years. Very hard to predict. And the videos that I'd like to show you, I'll show them to you in class, really tell the story of how El Ninos happen. You need to remember that the acronym for an El Nino is ENSO. El Nino Southern Oscillation. Why is it called El Nino? Because back in the day, the Chilean fishermen, this used to happen around Christmas time. And they would know it was a terrible time to fish, and they would call that an El Nino for little child. You know, little Jesus child. So that's where it got its name. Alright, last thing I want to cover in this video is something called the rain shadow effect. The rain shadow effect causes microclimates. Let's see how this works. And this really happens even right here in the United States, where we have the Rocky Mountains. I can remember traveling to El Paso, Texas. And El Paso, Texas is like on this side of the Rocky Mountains. And in fact, it's called El Paso because it has a pass. There's a way for you to drive and kind of cut across the mountains without going up to the top of them and come down in this area here. It's amazing how lush this area is here. And now you can see why. The prevailing winds for us, and you probably know this, most of our weather comes from west to east. So it starts at the Pacific and it comes across land. All right, here's California. And as these prevailing winds head up here, they are moisture laden. There's lots of moisture in them. But as this natural barrier of mountain ranges requires the warm, moist air to rise, the water evaporates and all the rain falls over here. So instead of having a normal rain situation, this natural barrier of mountain causes the rains to fall on the windward side, and that's what you need to jot down. A rain shadow effect happens when warm, moist air hits the mountain, rises up, and drops its precipitation on the windward side of the mountain. Well, once these winds find their way over the mountain and get to the other side, these winds are very, very dry. And so on the leeward side of the mountain, that's the area that doesn't have the wind on it, is very, very dry and arid because all the moisture has been dropped out of the air.
In addition to topography, vegetation can also create microclimates. Plants and trees cast shadows, insulate from the wind, and exchange water with the environment. As you can see, this is an arid and dry area, open to the sun and the wind, a climate typical of Southern California. The airspeed here is 0.6 meters per second. The temperature is 29.8 degrees Celsius, and the humidity is 55%. Now let's move to a new area. Now here, the presence of the stream and the shelter from the wind have resulted in the growth of a tropical vegetation. This is another microclimate. The wind speed here is 0. The average temperature is 22.8 degrees Celsius, and the humidity is 84%. What a significant change, and only a few meters apart. These changes, or microclimates, may not have significant effects on humans. But for smaller organisms such as plants or animals, these variations can mean the difference between survival and death. But on the other hand, this certainly is a beautiful place to enjoy.
All right, so what I wanted you to pick up out of that thing was this term microclimates. As the term indicates, it's an area, very, very small area, that has its own separate little climate. Not what you would expect. I mean, that's true over here on the leeward side of this mountain. If the mountain wasn't here, the warm, moist air would come and there'd be as much rain over in this area as there is over here. But the mountain gets in the way. And as the video showed us, it's not just mountains that can get in the way, but I'll tell you what, this would be a great representation to help you remember what microclimates are. So a rain shadow, over here, no rain, is a microclimate. And that would be a great way or a great thing for you to remember. Okay, bring your questions to class on these topics that I covered, especially the ENSO. That's a big deal on the ACE exam and the AP exam because it has such an effect around the world. Next up, we'll shift gears and we'll start talking about not microclimates, but major climates. Major climate areas of the world. You know, we can essentially divide the world up into certain very, very typical climates. For instance, tropical rainforest, desert. It doesn't matter where you are on the planet, the tropical rainforest has a lot of the same features. So do deserts, so does tundra, forests, etc. So we will go through each one of those in the upcoming video. But I'm finished for now. See you later.